In this video, we will talk about improper integrals. So let's say we have a integral from 1 to infinity, and we have this random function. So if you integrate this and you get like a finite number, then this will be convergent. But if you integrate it and you get infinity, it will become divergent. So let me show you some examples. So here we have an example from 1 to infinity, 2x to the power negative 3. And what we're going to do is we are going to get the limit of this. So we're going to plug in b for infinity. So this will be much easier. So b is plugged into infinity. 1 to infinity. 2x to the power negative 3. And this is just simple integration from here on out. So let's integrate this. This will be to the power negative 2 over negative 2. We could cancel out the 2's. This will be negative x to the power negative 2. And we can rewrite this as negative 1 over x squared. So now we're going to find the limit. So this would be the limit of b to the that is substituted for infinity. And we're going to plug in our numbers here. So, or plug it in for x. So infinity will be plugged into x and 1 would be plugged into x. So as you can see here, this would still be infinity to the power 2. This will become 1. And whenever we have an infinity as the denominator, it will always be equal to 0. So this would be 1. And this would be convergent since we have a finite number. So here we have another example. So first of all, we are going to plug in a for infinity, since this will make it much easier, and rewrite this whole thing. And for this case, we're going to do a u substitution. So the u would be equal to negative 2. That would make the derivative of u be negative 2 dx. And we can get our dx by dividing it by negative 2. So we can plug this in for dx. So let's plug in a for x, and we're going to plug in 0 for x, and negative 2 times 0, that would be 0, so e to the power 0 will be 1. So this would be just 1. We can plug in infinity here. Negative times a negative would be positive, so this would be plus 1/2. E to the power -2 to infinity. We can't really do that, so we would have to cross it out. And we are just left with 1/2. And 1/2 is a finite number, so this would be convergent. So let's take a look at this question. So we can plug in A for infinity. It could be A, B, or C, whatever you want to call it. It doesn't really matter. So A would be plugged into infinity. And we can't really do anything right now, so we're going to do U substitution still. That would make the derivative of this be just 1, or just dx. And we're getting that, so this would be 1 over u. And we know that the integral of 1 over u would be ln u, so this would be ln u from -2 to a. We plug in back our u, so x plus 4. We would plug in our values for x. So this would be x plus 4 minus ln -2 plus 4. Oh, now we are left with ln infinity plus 4 minus plus 4, that would be 2. When you have this type of question, when you have an ln in the infinity, it won't just affect this, it will affect the whole problem. So when you do ln infinity plus 4, that would be like, that will not be possible because and it will lead to an infinite number. So that will lead to an infinite number and that will affect the whole thing because we have both ln's here. So this would be infinity, which would cause the problem to be divergent.